Alright, let's do example 3. We start by doing 3a. We're given that 1 minus 10a divided by 1 plus 10a is equal to cos 2a over 1 plus sin 2a. We need to prove this. So let's have our left hand side and the right hand side. Okay, so we have 1 minus 10a, we change it to sin a over cos a, over 1 plus sin a over cos a. Right hand side we have cos 2a, then 1 plus sin 2a. Alright, sin 2a is what? 2 sin a cos a. This one we can as well change it, but for now cos 2a, let's just wait a bit. Want to see how this side will look like. And then here 1 we can say is cos a over cos a, even here is cos a over cos a. So we can say cos a over cos a, that is 1, then minus sin a over cos a. Then all this divided by cos a over cos a, which is this one, then plus sin a over cos a. Right, and then cos 2a over 1 plus 2 sin a cos a. Right, after changing this one, sin 2a. Alright, and then what do we do after that? Let's simplify the numerator and then simplify the denominator. Looking at the numerator, we have a common denominator, so this reduces to cos a minus sin a over cos a. Right, then divided by cos a plus sin a over cos a. Now we can see we have cos a minus sin a. So for cos 2a, maybe let's try using cos squared a minus sin squared a. Okay, over 1 plus 2 sin a cos a. Right, and then here we can see a difference of 2 squares there. Okay, right, this one we can multiply the numerator and the denominator by cos a. If you multiply this one by cos a, then multiply this one by cos a. Okay, this will cancel, remain with cos a minus sin a over cos a plus sin a. Or you can tip in times. Remember, if you say cos a, let me do it by the side. If you say cos a minus sin a over cos a divided by cos a plus sin a over cos a. Right, you can say this is cos a minus sin a over cos a times cos a over cos a plus sin a. You see that? Then this, so this will give you cos a minus sin a over cos a plus sin a. Right, then we have difference of 2 squares here, so we have cos a minus sin a, then cos a plus sin a. Right, remember here, 1 is equal to cos squared a plus sin squared a. So we can replace this one with cos squared a plus sin squared a and then create a trinomial. Okay, so we replace this. So there's going to be cos squared a. I want to create a trinomial that we can factorize. So I'll start by writing this part before I write sin squared a. So 2 sin a cos a, then plus sin squared a. So cos squared a plus sin squared a, that is 1, which is this. So now we can factorize this. Okay, remember, if I put this as an algebraic expression, it can be like x squared plus 2xy plus y squared. Then how do we factorize this? We say x squared times y squared, which is x squared y squared. Then we look for the factors of x squared, y squared, that can give us 2xy, which is xy plus xy, isn't it? So it becomes x plus x squared plus xy plus xy plus y squared, right? But you must know what this gives you. You must just know that this one will give you the bracket x plus y times x plus y. Okay, but let me just show you this. Then we factorize x and then x plus y, and then here common factor is y, and then get x plus y. Then you see that you're getting your x plus y, x plus y. We're applying this, so it means this cos squared a plus 2 sine a cos a plus sine squared a can give us cos a plus sine a times cos a plus sine a. Okay, all right. So cos a minus sine a over cos a plus sine a. Then we have cos a minus sine a, right? And then cos a plus sine a, right? Then this written as product of its factors will be cos a plus sine a times cos a plus sine a, right? Then this bracket divided by this bracket will give us 1. So what we remain with? Cos a minus sine a over cos a plus sine a is equal to cos a minus sine a over cos a plus sine a. Right, we prove that the left hand side is equal to right hand side. Okay, now we have to do part B. Right, part B says hence evaluate 1 minus tan 15 divided by 1 plus tan 15. So this means that we have to use our proof. 15 degrees is just like the A. So it means 1 minus tan 15 degrees divided by 1 plus tan 15 degrees. It's just same as cos 2 times 15 degrees over 1 plus sine 2 times 15 degrees, because we proved this. Okay, so this is equal to cos 30 degrees, then 1 plus sine 30 degrees. Okay, and then these are special angles. This is root 3 over 2. Then I'll say divided. I find it easier to do this. Divided by 1 plus, okay, and then sine 30 is 1 over 2, right, which means root 3 over 2 divided by 3 over 2, which is root 3 over 2 times 2 over 3, right? And then means the answer is root 3 over 3.